So here we're going to take a look at calculating a correlation from start to finish, and I'm going to follow along with the packet that I've created for us. So we're going to specifically look at and see if there's a relationship between the hours studied and the current GPA. So we're looking for a research question is there a statistically significant relationship between hours studied and current GPA? Which means that my null hypothesis is there is no statistically significant relationship between hours studied and GPA. And then my alternate is there is a statistically significant relationship between hours studied and GPA. So I'm going to move directly into my assumptions. And so my first assumption is that my variables are continuous. So you'll notice these have a scale icon because these are continuous variables. And if I go into my variable view and I'm looking at hours of TV, I can see that I have no values, so I shouldn't have any kind of value system, and it has been correctly marked as a scale variable. And then if I look at my GPA, again, I don't see values because that indicates categories. You shouldn't have those. And I do see scale. So basically in my write-up, I just need to say that both hours studied and current GPA are measured on a continuous scale, which satisfies the assumption for a correlation. And I'm going to insert my textbook's piece. The next thing I have to do is I have to do the linearity assumption. And so in order to do this, I'm going to have to make a scatter plot, and I'm going to have to look at it, and it should look like one of these two over here. So I'm going to go to my appendix, which is where the directions are located to do the scatter plot. And I'm going to go to Graphs, Chart Builder. I'm going to select Scatter Plot. I'm going to drag it over, and then I will drag my variables over, and I will click OK. So I'm going to go into my Graphs, Chart Builder, Scatter Plot. I'm going to drag in my scatter plot. I'm going to look for hours studied. And because it's a correlation, it doesn't matter which variable goes on which axis, because I'm just looking for a general relationship between the two. You can mess with your plots and your axis titles if you want to. You don't have to though. So here's my scatter plot, and so it does appear that I am seeing somewhat of a correlation happening here, somewhat of a linear relationship. If you're not sure if you're seeing it, then you can make some modifications in here, and you could add the line of best fit if you needed to kind of imagine what that line would look like. So you can definitely do that. But again, it doesn't have to be done. I was just looking to see if the directions are in there. So I can go back into my plot and add a line. If not, that is reasonably linear. The main thing we're looking for is that it doesn't appear to have a curve in it. So if you look at these data points, they have a very clear curve. And if I go into my SPSS output, I don't see that curvature present in there. Let me just pull it up again. So you see, I don't see anything that's curved. I just kind of see a line that's maybe somewhere around here. So it does satisfy the assumption of linearity. And it does look like it's closer to a positive relationship, but I can actually find that out once I get my correlation done. So I'm going to say we're good. It is linear. So I'm going to drop my image of this scatter plot, and I'm going to fill out my APA information here. I can skip over nonlinearity because it is linear. And now I need to test for outliers. And to do the outlier test, you're going to run Shapiro-Wilk. So I'm going to go into my appendix and look at Shapiro-Wilk because it tests both assumption 2 and assumption 3. So I've got to test for outliers while I check for normality. And so I'm just going to pop down to my appendix. And I need to go to Analyze, Descriptives, Explore. This is going to pull up my information. In my dependent list, I want to pull up my hours studied and my current GPA. And I'm not going to put a grouping factor because I don't have one. I just have a scatter plot. And then I'm going to go into my plots dialog box, and I'm going to make sure that I have made the appropriate check marks, which would be normality plots with test, and I uncheck stem and leaf. And so that is preset, and it's preset because I did this yesterday. So it would not typically be preset, but I haven't closed it down yet. And then it says I can click continue and OK. So here's what it gives me for my Shapiro-Wilk, which is over here in this table, and then this is what it gives me for my outliers. You don't want to look at the QQ plots, you just want to look at the box and whisker plot at the end. So I have 2 box and whisker plots, one for each variable, and you're going to see that I have an outlier right here, and then in the box and whisker plot here, I have another outlier. So I have an hours of studied per week outlier, and I have a current GPA outlier. So when I go into my data set, I've got a decent amount of data. I've got 50 data points. But for me personally, I don't like to remove outliers when I have less than 100 data points. So for me, I think what I'm going to do is leave these in because I have only 50 points. So by removing one, I just kind of feel like it might not be great. But I will come back to that if something looks odd. So then I'm going to go into my Shapiro-Wilk, and I'm going to look at the significance for those. I have 0.003 for the first one and 0.1 for the second one. And so let's find out what that means. So for Shapiro-Wilk, if it's greater than 0.05, it is normally distributed. So that means that students' current GPA has a normal distribution. However, it means that hours of studied per week is not normally distributed. So at this point, I'm going to consider if I take out the data point for the hours studied per week, that is the outlier, maybe that would make sense here. Let's just kind of go in and look at that data point. So I have an hours per week that's somewhere between 30 and 40. Let's see if we can correlate that. So I have a 30 here, a 30 here. So it looks like this 38 is probably the outlier because it's between 30 and 40, and I've got a couple of 35s. So what I'm going to do is I'm going to delete this row. And I'm going to cut that row out, which is going to change me by 1, and I'm going to redo the test. So I'm going to go back into Analyze, Descriptives, Explore. I've got my 2 variables. My plots are already checked, and I just want to see what is the impact there on that significance value. So now I don't have an outlier for hours of studied per week because I took it out, but it still is not normally distributed for hours of study per week. So what I can say here is it's not distributed, so it is going to violate normality. So if it is not normally distributed, you can consider doing Spearman's rank correlation instead of Pearson's correlation. And all it means is that a different thing is going to pop up. So I'm going to go ahead and do Spearman's because the normal distribution is violated. So I will not do Pearson correlation. So I'm going to insert my Shapiro-Wilk image. I'm going to clearly state my follow-up. And then I'm going to go in to do my correlation. So I'm going to go into Analyze. I'm going to go into Correlate. And I'm going to go into Bivariate. I'm going to move my 2 over to my variables. And I'm going to uncheck Pearson and check Spearman because I have violated normal distribution, so I'm going to use Spearman. When I use Spearman, I need to make sure I go into options, whether it's Pearson or Spearman, and I need to make sure that I've got this information looking exactly like this, and I exclude cases pairwise, which is selected. So I'm good there, and then I can click OK. So you're going to notice this is going to give me my Spearman box here. And if I go into my outputs, you'll notice I don't have my descriptive statistics, but I can run that separately because Spearman is only going to give you this table. And you only want to look at what's up here in the upper right-hand corner because there are duplicates basically. So my upper right-hand corner gives me 0.258 for my correlation coefficient and 0.073 for my significance. And so as I am thinking about that, I will need to report this out. And remember, I have 49 data points. So I'm going to, 49. So I'm going to subtract 2. So it would be R of 47 equals, and in this case, I have 0.258 would be what I would write. And then my p-value would be 0.073. So if I'm looking at interpreting this, my R value that I found is 0.258, which falls here and shows that there is a very small correlation. And because it is positive, that means that as the hours studied goes up, so does the GPA. And then if I look at my significance, my p-value has to be less than 0.05 for it to be significant. Here, my p-value is bigger than 0.05, so it is not a significant correlation. So that means that these are not significantly correlated variables. They do not have a significant relationship. There is a tiny correlation between them of 0.258, but at the end of the day, because that relationship is not significant, I'm not necessarily going to make strong decisions that force more study time with higher GPA. So I wouldn't institute a study hall, a study period as far as an interpretation of this, because implementing a study period is increasing the hours studied, which again is not significantly related. So any interpretations and suggestions that I would make in my chapter 5 would be geared around understanding that while there's a small correlation with this, there are other things in play that may have significant relationships. So it would be better to explore those things to look at getting that increase in GPA for the student body that I'm studying. And that is how you do a correlation in SPSS.